All right, so I'm Orion from Meta, PyTorch Edge team, and Mergen as well. So we are going to present some of the work that we've been doing for OnDevice AI. And hopefully you were able to see some of that during the deep dive just this morning. We just launched some really exciting stuff. So this is really years in the making, though. There's been a lot of work done by the team to get us here. So this is, but I'm really excited to be able to talk about this with all of you. So with all of this, I want to start with some history. So PyTorch has been really good at empowering AI researchers. And we've been able to do this on the server, but the mobile and the edge story has been kind of a more challenging area. So if you think about, so we had, in 2019, we launched PyTorch Mobile, which had iOS and Android. And in fact, this is used a lot internally at Meta. But in open source, we really have seen a little bit more of a challenge in adoption. And so a lot of people were using Onyx and TF Lite. So with all of this, we really wanted to reset what our kind of strategy was here and embrace the spirit of PyTorch. And so this is productivity, hackability, and debuggability, and also being really collaborative with the community. And so this is kind of a new opportunity in some ways for us. So OnDevice does have these unique opportunities and also challenges. So if you think about, you need 60 frames per second when you're talking about computer vision things. You're talking about AR, VR. You're talking about, places where you're using very sensitive information in data. But you also have real opportunities to personalize to the end user. And ultimately, with all of this, it's about enabling new experiences. So let's say it's wearables with being able to track biometrics, or within cars being able to do self-driving or other things like that. So with all of this, it does require new approaches. And this is something that that has been worked on by us and by others. So I just wanted to call out. There really has been a lot of work in this space with, by ARM, with TOSA, Qualcomm, with QNN, with Apple, with CoreML and MPS, and I think also Google with TF Lite, and I'm sure I'm missing a lot of others. There's a lot of them are actually at this conference. So I just wanted to say, there's been a lot of work in this space to try and get this right, and our approach wants to match to that opportunity that there is all this work that's been done to have high-performance AI on device. So some of the things that makes PyTorch unique is really the design principles that we have. So usability over performance, simplicity over easy, and being Python first. And so we wanted to take these design principles and bring them back and really rethink what is needed here. So with usability, it's really about keeping people, giving people a real kind of flexible and hackable environment to be able to do this work. Simple over easy is about having things be debuggable, understandable, having introspection. Easy is really about magic, and we don't want to go there. We really want it to be understandable. And Python first is, of course, a core thing with PyTorch, and so we want that here on the on-device solution as well. So we made some key trade-offs to get here, which we'll cover later, but ultimately it's about simple tools for a complex domain, and that's really what we're trying to provide. So with all of that, I just wanted to introduce ExecuTorch. This is really the culmination of work that's been done by the team for a while, for multiple years. It is in preview. It's MVP right now. It's actually live. We just launched it this morning. And we're keeping PyTorch Mobile, which you all know, up and available, but we really want to showcase the new approach that we have with ExecuTorch. And so this is able to leverage a lot of the PyTorch 2.0 and 2.1 based export and other technologies, and then get us to not just iOS and Android, but also to embedded environments. And it's shipped right now on Ray-Ban smart glasses, Ray-Ban Meta smart glasses, and is coming to Quest 3 soon. So why did we build ExecuTorch, and also why should you use it? So first of all, just like I talked about earlier, ExecuTorch is PyTorch. So we use things like export. We have quantization that goes across the stack. So you're talking about using the same quantization logic during your initial development and training phase, and having that be available on device. We have core A10 ops, which is a way of having that parity between what you're seeing in training time with inference. We also have delegation. This is actually very core to how ExecuTorch works. And delegation is a story of partnerships. And so with this, we've been able to work with ARM, Apple, and Qualcomm to be able to provide different lowering techniques and paths to the hardware through really optimized kernels. We also have an SDK that wraps around all of this, so you can then go and debug and figure out where the challenges lie. The modularity is also a thing that Mergen will talk about, and then the overhead and runtime has really been reduced greatly. So we're talking about from 1.5 megs all the way down to 40K. So, and again, just really focusing on the developer experience is something that we feel is really important. So to do all of this, we did make some pretty big trade-offs, and the right ones, I feel. We focus on ahead of time in as many cases as possible, so you can do things like memory planning. You can do different kind of optimization passes. There's just a lot of control and a lot of hooks that we provide to be able to do things in an ahead of time way. And that also helps optimize and streamline what has to be done in the runtime itself. I talked a little bit about delegation. That's a very important part of the story here. And then Python being the environment that you're mostly living in when you're working with ExecuTorch. And then lastly, just being able to limit the types that we have here and focusing on, basically like a subset of types, but then also giving extensibility through things like PyTree, where you can actually have a composed type through all of that. So there are ways that we work around the constraints that we've imposed on ourselves here. So with that, I'm going to pass it off to Mergen to talk a little bit more about the technical side of things.
Thank you, Orion. My name is Mergen. I will talk a little bit deep into the technical sides of the ExecuTorch. So the problem statement is that we have a PyTorch model. We want to do inference on device, right? So this is the problem we are trying to solve, and it goes through multiple stages. It first uses the torch.export to generate the semantically equivalent graph, and once that's done, you go through various transformations on the graph and compilation to target specific hardware. And then once you generate an ExecuTorch program, you can load it into your runtime and be able to execute it very efficiently. So this is a very high-level recap on the overview of ExecuTorch. So today I'll go about 3 key benefits of ExecuTorch. So the first one is we are leveraging torch.export. So in order to generate the semantically equivalent graph, we use the torch.export. It is really the underlying mechanism for all the developments, innovations happening in PyTorch. Export that is really concise, but really powerful, that it can capture dynamism in PyTorch program. And as a result, you don't have to do a lot of things to convert from a model to a graph. So it's another thing is that we are actually focusing a lot on minimizing the number of ops we need to support. vendors need to support, partners need to support. So we are limiting to about 200 or so operators. We are calling it Core A10 operators. And lastly, this, one of the benefits of this is that it's really the consistency between the authoring flow and the deployment flow, right? So as a result, you can actually be very sure that there's no inaccuracy happening because of this. So this is the first benefit. The second benefit is really like a conversion story, right? So as of today, it needs to get either converted to an Onyx or TF-Lite Micro, all the frameworks that Orion mentioned earlier. So I will go deep into like 3 things. So as of today, we really need to use like a very hardware-specific tool chain, right? So on the other hand, what ExecuTorch provides is that it provides Delegate. So Delegate is I'll talk later, but it's basically a building block that you can hook into very vendor partner specific implementations of compiler passes and runtime. So in the past, we've been hearing a lot from customers and developers that because of the conversions, there's a lot of lack of consistent tooling and debugging. So in ExecuTorch, we are providing this first-class native debugging and profiling support. And as a result, not only you can figure out what op is taking a lot of time, but you can also even dig deep into a delegate specifics of the delegates and profile the internals of the delegates. So lastly, a lot of times conversions, failures happen during conversion, from one operator to one format to another format, right? So one of the design principles of Delegate was to actually, we provide this kind of progressive lowering. So before it was like all or nothing, but now you can lower it progressively, parts of the graph to target specific hardware. So this is the second benefit of ExecuTorch. And as a result, you can stay within the PyTorch ecosystem to deploy OnDevice AI. This is also in the philosophy of PyTorch in general, right? But specifically, we applied it to ExecuTorch as well. Developers can pick and choose different optimizations through well-defined APIs. So in this diagram, I'm going to zoom in a little bit. So it's expanded now. So developers, as I said, developers can pick and choose. So this is one example. So from an export graph, you go through a quantization flow. We define, we have a talk later in the second talk. After this, we'll talk about the quantization. And then we also go through delegates, for instance, compile certain subgraphs into a binary blob that the target hardware can understand. And then you can also do a lot of custom things that you are interested in. So for instance, memory planning. And these all have different benefits. For instance, reducing the model size, reducing the latency, reducing the dynamic memory runtime, dynamic memory during runtime. So this is just one example. And as I said, we provide a Python API that you can plug in different building blocks to tailor towards your specific use case. And this is not only for the runtime, for the ahead of time part. This customizability and modularity is also available in the runtime as well. So where the Mingwei and Angela would talk next. Fourth is delegation. So as you can see, for instance, if you want to delegate into certain target hardware, we have a delegate available, delegate into, for instance, Core ML, delegate into MPS, or delegate into ARM backends, or delegate into Qualcomm. This is all available right now in our code base. And this is really important because the ecosystem, we need to work collaboratively to be really successful to provide the best user experience to the users, to the end users, right? So what it means is that developers stay still in the PyTorch ecosystem, but still provide performance on the target hardware. So this is the fourth benefit. And lastly, I'm just zooming in, zooming out. Now this is the whole flow, if you remember. So I would like to talk a little bit about the runtime part. So this is the runtime that is actually running on the edge device. So we designed the runtime to be very portable and very lightweight and nimble, right? So it was written in this very embedded-friendly C++ that's portable. You can either run it on a high powerful mobile device as well as a microcontroller. Like we have demos, for instance, going through ARM embedded device, bare metal, extensive DSPs. So these are some of the design decisions we made. For instance, no, we don't have any assumption of the OS. We abstracted it away. No dynamic memory allocation, and being able to plug in different kernel implementations, both the optimized kernels or our third-party kernels. So, and the runtime is, as Orion said, it's very small. It's about 40 kilobytes right now. So this is the 5 benefits that I wanted to highlight in this talk. But on a high level, we really want to focus on portability, which means can it run on a wide range of devices? Productivity, can the developers actually move fast and to deploy on device? And lastly, performance. Can it provide really good user experience to the end user? So, and we have talks, as I said, both the developer experience and the partner integration journey, and later, right after this. So this is still early. Today we are launching. We want to get feedback from users, embrace the community. And later next year, we have alpha release and beta release. You know, we want to harden, we want to make it much robust. We want to focus on enriching the SDK experience. And also provide a much better, higher, even more higher performance guarantees on this. So, all right, let's see. Oh, well, okay. So, you know, you might be wondering, you know, whether we can run Llama 2 on ExecuTorch. So maybe it, you know. Meta, Llama 2 came out of Meta, you know, we are working with Meta. So, so the truth is that it is possible, but we also, in order to provide the best user experience and the performance, we actually identified a lot of optimization opportunities, right? So int4 quantization is efficient KV cache, and you know, being able to compile dynamic shapes, and lastly, speculative decoding. So these are specific optimization techniques to enable Llama 2. But, so I would like to actually step back and clarify one thing. ExecuTorch is, first and foremost, a library, a framework that instead of designing something on a vertically, a monolithic stack, one can actually either take ExecuTorch and plug different optimization techniques to run Llama 2 or any other models a very performant way. So this really enables the community, enables anyone to run a Llama 2 or like these large language models moving forward. So yeah, also a few other things we would like to mention. So we did a lot of work on quantization. So you know, there's a whole different quantization flow that, you know, if you've seen, we had a poster session. Jerry had a poster session yesterday. So this is going to be and it is quite related to on-device, but this is going to be the moving path forward for the quantization. And there are different, as well as these other innovations that's happening in this space. So we are Really excited about the on-device AI space moving forward, and we want to say that this is ExecuTorch is the solution for deployment moving forward, and we are investing a lot in this effort. So, all right, with that, thank you so much. Yeah. Yeah, I thought that was the last slide, but so yeah, so pytorch.org/edge, you can see both the ExecuTorch and also our Torch script and more legacy PyTorch mobile solutions there. But we have a brand new now repository, pytorch.com. It's fresh out of we just announced it this morning at 9 o'clock. So try it out. And yeah, thanks so much. Yeah. Bye-bye. So we have Mingwei and Angela gonna talk about developer experience, but I think there's like a bathroom break, 5 minutes, 10 minutes bathroom break, bio break. So if you're interested in learning about the developer experience end-to-end, check out their talk. Later on, Kimish is gonna talk about, Kimish and Chen are gonna talk about partner integration stories. So.
Yeah. Also, there's a demo booth upstairs that everybody should check out later on, where we are kind of showcasing a lot of the work that's being done here on real hardware and devices. So yeah, check that out. Cool. Thanks, everyone.